Welcome to my talk. I'm going to talk about the Elastic Stack, and I'm going to talk about how we test the whole stack, but also how we test Elasticsearch itself. I used to be an Elasticsearch developer for the last 6 years, so at least I know what we test and how we test. And so we basically work throughout how we test Elasticsearch, how we test the stack, how we release the stack, and what kind of work we have to do when we release the whole stack. Who of you uses Elasticsearch, Logstash, Kibana, or anything? Just a quick hands up. All right. Who of you uses Elasticsearch version 6 or the stack version 6 and above? Hands up. Version 5? Okay, version 2? Don't. All right, but this means we have to maintain versions for some time, and that's what I was after. And I especially also want to talk about releasing, because no matter if you have like open source code or commercial code, if the code doesn't run on your customers or user systems, it doesn't exist. If I just push code to GitHub, it's nice that it's open and in the GitHub repository, but no one gains any value from that unless we release the artifacts that contain the code we worked on. So I think releasing is a super important step to the whole process. Yeah, quick intro about myself. Those who heard my talk yesterday can just grab another coffee now. I'm Alex. I joined Elastic in 2013. I'm part of the Elasticsearch team, so if you have any Elasticsearch questions, I should probably be able to answer them. Elastic is a fully distributed company, which makes working very interesting. On the one hand, I work from home and have a lot of independence. On the other hand, time zones are really, really bad, especially in the US or Japan, so you've got to stay up late every now and then. The company itself is basically the whole driver behind the Elastic Stack. You may know Elasticsearch, Logstash, and Kibana. Turns out that pushing to GitHub repositories doesn't make you money as a company, so we obviously have a commercial ecosystem around it, like running these products as a service or offering consulting and support subscriptions and trainings. So this is basically the whole company. And this is what I want to talk about today. I want to talk about the quick introduction, what is the problem and how we want to tackle it, how we test within Elasticsearch. So if you're a Java developer, there might be a couple of interesting bits in there, how our CI setup looks like, what we do and how we do when we have to prepare a release. As you probably figured out, we don't have anything like continuous delivery because we don't run the product as a service, but we have to have fixed releases for our users. And the last thing, obviously, is doing the release and not screwing it up. So let's do the quick introduction. I already hinted at the Elastic Stack being Elasticsearch, Logstash, Kibana, and Beats, like our main open source products. There's a client for Elasticsearch, which is not only just a client in terms of an HTTP interface for different programming languages. It's basically a bit more because it can do failover, these kind of things, so that it's as easy as possible in any programming language that you have to interact with a whole Elasticsearch cluster. And those are the open source parts, right? But there are more parts to it. There are commercial parts which need to be released as well with every release. There's our service or our Elasticsearch as a service system, Elastic Cloud, which runs Elasticsearch, Kibana, and APM as a service. And we want to make sure when we release a new open source version that our Elastic Cloud system also runs this version immediately with the release. So there's a lot of stuff to think in the background to make this happen. We also have a couple of products which basically set up on top of Elasticsearch, like App Search and Site Search, which are commercial products on top. There's APM, Application Performance Monitoring, which has a couple of own systems or own servers. So these are all things that need to be sort of released at the same time. And this means it's just a lot of different systems where we have to make sure we're in sync when we go out and tell people, look, we released a new version. So there's a lot of work happening before we can do that. So how does it look like? Basically, all of our products are written in different programming languages. All of our products have different dependency management systems. All of our products have different release mechanisms. We have Elasticsearch in Java, Logstash in JRuby and Java. Beats are written in Go. Kibana is written in Node.js. So we pretty much have all the different systems in place that you can imagine. And it's a good thing on one hand because every team can work with its favorite system. Every team can work with its own ecosystem. But it means as soon as you want to do a release, you have to try and like fiddle with a ton of different systems and make sure everything works. IPM is, the server is written in Go, but we have instrumentation agents, which are again written in their respective languages. Our commercial code is written in C++, Scala, Ruby, Go, and of course all of the products above have commercial extensions. Tooling, of course, tooling has to be written in Perl, even in 2019. Our documentation generation, for example, is a really big Perl script. And of course, you have Python, Node, Ruby, like all this kind of scripting languages. Gradle is used in Elasticsearch as a build system. We have the Elasticsearch clients written in their respective languages. So there's just, a lot of code, a lot of different code, a lot of different languages, which at some point we have to, unify. We don't do continuous delivery, I already mentioned it. We have like a static release, Elasticsearch 661 or something, and that's the version we push out. In the past, we kind of, every team, like Elasticsearch, Logstash, Beats, Kibana, released when they were ready. So we had different release dates. This pretty much looked like this. Like, we released a version, and at some point, someone else released their version, and we basically offloaded the burden to the user to decide, like, Kibana 4.1 works with Elasticsearch 1.6 and with Logstash 1.5. So you kind of ended up with a compatibility matrix from hell. And we told the user, oh yeah, look, you have to take care of that. And this, of course, is not really an acceptable solution. So we set out and find what can we do. And we figured out, like, we could do this. We could just release all the products at the same time. Which means if you use Logstash 5.0 and you use Elasticsearch 5.0, you can just be sure they are compatible with each other, they work together, there are no gotchas. You just install them and everything's good. This also meant that this whole synchronization between the products was basically back on our shoulders. So we had to make sure that when Elasticsearch 5.0, 6.0, whatever is ready to be released, that also the other products are in kind of a releasable state and we can release them at the same time. And this is a huge effort, and I'm going to talk about that later, but it made it so much simpler for all the users to just download the same versions of every product and get up and running that it was well spent time from our perspective. And also with this sort of mechanism, it's not super bad if you don't make a feature, you can just push it to the next release because we have pretty frequent releases. There's always one of the products having a new bigger feature, always one of the products having or requiring a bug fix where you have to release a new version. So this kind of many products releasing at the same time also ends up with a fair share of releases. So how do we test and what do we test? This is more kind of the Java side of things within Elasticsearch. So Elasticsearch is a pretty massive test suite nowadays. Most of the tests or pretty much everything you do within Elasticsearch is in Gradle. We try not to have any other dependencies, so we have a ton of self-written Gradle plugins on top of that. But let's start at the lowest level. We have a ton of different tests. And you may recognize most of those, like unit tests, and I'm going to talk about each of them in a bit more detail. So first things first, unit tests. Those are the ones which are small, fast running. You can easily run them in the IDE. You get immediate feedback if your test is passing or not. They just look like regular unit tests. You have assertions in them and so forth. The interesting part here is the class the unit tests all extend from. It's called ES test case, Elasticsearch test case. It sets up a couple of things like custom loggers if you should need them. It allows you to easily set log levels. If there's a flaky test and you would need to get more log levels, it's super easy to configure that for those kind of tests. The interesting part is basically the parent class, the ES test case class. And here we have a couple of things which are required for Lucene setups. Lucene is a full-text search library used within Elasticsearch, which has a couple of interesting setups, but the interesting part is basically this. There are listeners, and there's one listener called reproduce info printer listener, and we will get to that one in a second. The interesting part is also the comment. We say there's a base test case for randomized unit testing. So what the hell is randomized unit testing? Regularly normally when you test things, you have some input, you run a function on it, you get an output. And usually this input is static, right? You set a certain string, you assert that the expected output string is whatever the function should do, and that's it. Lucene, as a full-text search library, has kind of a different mechanism. Lucene is supposed to be fully UTF-8 compliant. So instead of just testing with strings, instead of just testing with maybe only ASCII-based strings, they have functions, for example, to create random strings which are UTF-8 compliant, or functions to create a random number between whatever range you specify. So you can get any kind of randomized data out of it. However, if you have tests with random input, you also get sort of random output, which may not be the intended thing. And the important part is when you start doing this, it needs to be reproducible, right? You have to have a mechanism where you can say, I'm starting with this random seed, and I can be sure the same random numbers get generated, so you can reproduce a test failure. And this is exactly what this reproduce info printer is for. It tells you the seed where a test failed with, and then you can just run the same seed and create the same seemingly random numbers. And this is a super important test feature for many things that we do. This is one of the reasons why we don't have a lot of fixed strings in our tests. We always have to try random strings in there, which is especially important for search. And we don't have to do anything as a test setup. It's part of our global test class. So whenever we extend any of our test classes, we have all of these randomized functions readily available. And the logging listener here basically is just a listener which allows us to watch the state of test runs while running within Gradle. It's just a status report. The other interesting part here are the last two annotations about thread leaks. So basically all of our tests run with the detection of leaked threads. So if you started a thread but you didn't stop it, the test will basically fail. Because something that we don't want is kind of a resource leak regarding threads. Threads are an expensive resource, so you don't want to leak them in your system. So the next level would be integration tests. Elasticsearch is using Google Juice for dependency injection. We kind of try to get away from it, but it's a lot of work. And we've been reducing the use of Juice over the years, but it's still there. And this also means that at some point you sort of have to run this Juice dependency injection setup to basically test certain test cases. And this is basically where this ES single node test case comes into play. It's doing all this dependency wiring, and from then on you can use components which have resulted from this wiring and test them. And the second test class we basically have is the integ test case, which is a bit special, because what this is doing is it's basically running several Elasticsearch instances in a single JVM. So we can kind of form a cluster in a unit test, if you want, that you can run within your IDE. So we have tests where two nodes are started, and we can make sure that Elasticsearch works. This sounds nice and fancy, but it also has a disadvantage, because in production, we never run two Elasticsearch nodes within a single JVM. You always have a one-to-one mapping. You always run one Elasticsearch instance in a single JVM. So this test is doing something that we never do in production. And that's a bad thing. If you have tests, make sure they are as much production, running in production as it can be. So what would be the proper workaround for this? The proper workaround would be that you really start Elasticsearch externally and then fire your tests against that. And this is basically what we do when we run our so-called REST tests. So Elasticsearch uses HTTP and JSON for the communication with anything external. And this is kind of the part where we want to make sure that this interface is working as expected. This is our outside interface to the world. So what we basically did is we have a definition of all of our endpoints in JSON. You can see here the potential parameters that can be used. You can see what kind of types those parameters are. Is it a list? Is it a number, a Boolean, these kind of things. And we basically have this whole description. And based on this description, we also have a test suite. This test suite is written in YAML. And you can see here that we are basically calling certain endpoints, like the cluster state or the nodes info endpoint, and we can fulfill certain assertions. Why did we write this in YAML and JSON instead of Java? The reason for this is that all of our official Elasticsearch clients, no matter if written in Perl, PHP, Ruby, Python, Go, or whatever, they can reuse these tests to make sure that the client has all the functionality that they require to run against Elasticsearch. So basically, all of the clients in test mode, they're reading the JSON endpoints, and then they're running those tests as well. And the nice part is that the Elasticsearch developers maintain those tests. So if we add a new API, we also add a new test here, and the next time the client people are running those tests, they will immediately spot that they are missing an endpoint. And this way, we basically make sure that all of our official clients are up to the same level and can support the exact same features. So the REST tests serve basically two purposes: test Elasticsearch and also test all of our official clients. Packaging tests. At some point, you're going to create an artifact of the software you create. Like this could be a jar file or a WAR file in the Java world, but you create something that you can hand over to the customer. In the case of Elasticsearch, this is basically 4 artifacts. We have a zip file, a targz file, we have a Debian package, and an RPM package. And we want to make sure all of those artifacts can actually be installed on customer systems. What could be a potential customer system? You can see here we have a list of Vagrant boxes which resemble Linux distributions and their version, and even Windows at the bottom. And we want to make sure that our RPM, our Debian package, our targz, and our zip archive work. So if you've ever had the fun of dealing with package management systems, especially RPM and Debian, you will notice that they act very differently on the different Linux distributions. There are still a couple of LTS releases in there where you have System 5 in it and you don't have System D. Also, the startup mechanism of Red Hat and SUSE, for example, is super, super different. So we only have one RPM, we only have one Debian package, so we have to make sure that those packages work onto all the different distributions. And the only thing you can make this sure is that you make sure you have a ton of automated testing around this. So what we basically do for packaging tests is we spin up a Vagrant virtual machine for each of those, and then we run the files which are in the below test folder. And you can see there's something called .bats. .bats stands for Bash Automated Testing. It kind of allows you to write something similar to a unit test in Bash. So what we basically do here is we install the Debian package in one test, we verify that the Debian package is installed in another test, we make sure that one can start the installed Debian package properly, that you can shut it down, that you can remove it, and that it gets fully removed. So all of these kind of tests are basically covered within a single bats file. The unfortunate thing is that this bats thingy is not really further developed, so we're thinking of switching this into our Gradle build. But at least we have the confidence that all the Linux distributions which we officially support, our packages are working as intended. This is super, super important because you just have to test the artifacts which you're really producing at the end for your customers. Next up, documentation. Who of you tests their documentation that they work with the actual version you're releasing and sending to your customers? Hands up. Automated? Almost, okay. So this was one of the things which of course bit us as well. So for all of our all of our products, our technical documentation is written in ASCII-Doc. ASCII-Doc is like Markdown, but more powerful, more functions, nicer to customize. We have a couple of interesting special features in there. And so we have this ASCII documentation, which is part of each of the products repository. And of course, we have a ton of snippets in there where we show, like, this is how you can do a search, this is how you can index a document, this is how our bulk API works. And over time, like, your API changes, but your documentation does not. And then you just copy paste an example and it doesn't work, and it's super frustrating. It's like, this is the first kind of experience people have when they take a look at your documentation. So we basically invested some time and created an integration test within our documentation, which fires up an Elasticsearch node, searches for all of the snippets, which are marked with the console comment in there. So the // at the beginning is a comment in ASCII-Doc. It doesn't get rendered out. And if it contains such a console comment, this is considered to be a piece of code that is run as a test for the documentation. So in this example, we will basically run a GET request against /Twitter_search with that parameter. And if the response is not an error, we consider this to be a successful run. There's another kind of comment down there, which is test setup Twitter, which just says you need to run the Twitter setup, which creates, in this case, a Twitter index and index a couple of documents in order for this test to run. So this way, we test all of our snippets that contain the console command. Of course, you are not really satisfied when you only get back an HTTP 200 as return, because you want to make sure you can also test the contents of a response. So we basically sort of extended this over time. And you can basically, when you are inside of a single ASCII doc file, you have some sort of before method where you can make sure that this code here is always run by setting the test setup comment over there. So we can be sure that we have these two documents indexed. And the other part is, which is super hard to spot because it's at the bottom of the screen, is that you can also test responses. So at the bottom, there's a JSON response, which should be returned by the one query, which is sent out in the middle. And this way, we can basically make sure that the response that we expect is actually really returned by Elasticsearch. So not only the request is adequate and correct, but also the response, which is in our documentation. And I think we have more than 1,000 tested documentation snippets just in the Elasticsearch docs, and it turned out to be super, super useful, especially when you introduce new APIs, especially when you change existing APIs. We can always be sure that our documentation is up to date, that the examples are up to date. Like, this is a huge feature, even if it looks small, but documentation is just such an important piece for users that you should always make sure you're up to date with it. So what else do we have? We have something which we call smoke tests, which sort of resembles what I mentioned earlier, that we are basically starting an external Elasticsearch node, and then we're able to run tests against it. And this external Elasticsearch node may have some special configuration which is required for this test. For example, there's an ingest disabled directory here, where we disable a certain feature, and we want to make sure that some functionality is not enabled in that case. So we have a special Elasticsearch configuration. We fire up the node, or even multiple nodes, run the tests, and bring them down again. Or we had a feature at the bottom which is called tribe node, which allows you to search data across several clusters, which means that we have to have a test which spins up several clusters, executes searches, and shuts down again. And all of this, of course, is something we could test manually, but we can also just automate it over time, and there's still enough things to test manually, right? So those smoke tests are really, really important for us to test more complex features, which require more complex setup than just a single node. The next thing is backwards compatibility. This is, I think, one of the most important features. So Elasticsearch, since version 6, basically guarantees that you can do a rolling upgrade even when you upgrade major versions. So the basic idea of how to upgrade Elasticsearch is, on the one hand, you could always do like, shut down all your nodes in your cluster, update the nodes, and bring them up again. But of course, this comes with the disadvantage of downtime. Most of the time, you don't want to have downtime, so we propose people you should do a rolling upgrade. You bring down the first node, you upgrade it, you bring it up again, you make sure the cluster is stable, you bring down the second node, you upgrade it, you bring it up again, and you do this until you basically upgraded all of your nodes within your cluster. And this is our proposed, or this is our documentation statement, but this also means we have to test it. And this also means we don't want to test it in a non-automated way. We want to test it whenever we push code to the repository. So we have exactly this kind of backwards compatibility test. We have one test that is doing a full cluster stop, upgrades the version and starts again, and then runs a couple of tests to see if everything is running. But we also have the rolling upgrade tests, here the last one, where we basically spin up a 3-node cluster and then do this rolling upgrade and ensure everything works after we finish the rolling upgrade. There's also a couple of other features. We have a mixed cluster test because we want to make sure that if you have different versions of Elasticsearch running, like what automatically happens in a rolling upgrade is still supported, and the serialization of data is also working as expected. There's also a feature called reindex, where we can basically configure a node to reach into another cluster and read all the data and index it locally. And we want to make sure that this works with really old versions of Elasticsearch. So we have to make sure we have tests for this. And this is basically what all the backwards compatibility tests are doing. And I think it's also super important when you have your own products that you make sure that they still properly work, especially when you have a stack. When you have several different products where it's pretty sure that you cannot replace them all at once because you would have to shut down half of your entire architecture. then those kind of backwards compatibility tests, hard word, are super, super important. QA tests in general. We have more of those tests where we fire up an external node and then see if something is working or not. I talked about most of these. You can see there's a vagrant directory here, the full cluster restart one. There's also a whitefly directory at the bottom. Whitefly is a JBoss container where we kind of verify that our Elasticsearch client is actually working within a container environment, so where other people would use the Java client. So these are things which need to be tested as well, but the test setup, of course, is pretty complex because you need to like spin up a JBoss container, spin up Elasticsearch, start up a client within the container and see if everything is working. Okay, so this was the Elasticsearch testing part. We basically went from small unit tests to the like really long-running tests. Running the full Elasticsearch test suite on my notebook would take a couple of hours, and that one has 4 cores. So our CI has a ton of really, really fast machines to reduce the time. This is kind of our Jenkins setup. You see I probably spotted a bad day where there's a lot of things red. And I think it's like 9 nodes, but we continuously extend our setup, so we have quite a few jobs in there. We also have quite a few parallel runners in there, and I'm going to get to the point where I explain why we have so many of them. And even the jobs you saw configured at the top, they can spread into sub-jobs. So in this example, you can see that we have sub-jobs per Linux distribution because we want to make sure that each of the Linux distributions is supported and the tests are passing on them. So there's just a lot of things that run, and there are a lot of things of CI that always run in parallel. We also feed all of this data back into Elasticsearch and Kibana, so we can see like how many tests or how many test runs are actually failing, how many tests are passing. You can clearly see here all the down spikes are basically weekends. So most people tend to work during the week. That's a good thing. And you can also see that there's a fair share of test failures going on. Sometimes it's the test, but given the size of the setup, just a network hiccup on AWS systems may lead to test failures. So not everything that is red here means that we broke our code. Like given the size of the setup, there's always some sort of noise in there, and it's sometimes really, really hard to distinguish between noise because, I don't know, some repository is not reachable or of a real test failure. Benchmarks. Who of you is doing nightly performance benchmarks with their products? 2.5, 3. Okay, so we didn't do this for some time either, but at some time, I think like 3.5 years ago or something, we decided we should probably do this as well because it turned out it's pretty hard to spot performance benchmarks. Sometimes all it needs is a logging statement at the wrong position and your performance goes down 20%. Your indexing performance. We had this 2 weeks ago, and it was really nice to see or to spot in a graph like, oh, this looks bad, we should probably check the commits from yesterday, what could have caused this. It still takes you some time to figure out that it's a logging statement, but at least you have an indication what happened. So basically we wrote our own tool, it's called Rally. It's a Python tool which is able to spin up a cluster, which is able to load data into the cluster, which is able to run queries against it and measure all of this continuously. One of the nice things is you can also configure the Java flight recorder with it, so you can basically see the most common method invocations if you take a look at the recordings and start debugging from there if you have a hunch what could possibly be wrong when there's a downgrade in performance. So Rally consists of something that is called tracks. A track basically is a mixture of a data set and the queries which are fired against that. And you can see 2 tracks at the bottom here. There's a geonames track and the geopoint tracks. The geopoint, for example, indexes a lot of documents with a latitude and longitude, and then runs queries which are mainly geo-based. And again, all of our results are just dumped into Kibana, and we visualize the output. So we have a website where you can check our nightly benchmarks. And this one is actually a good example. If you look at the top left graph, you can see that there's a kind of 10% drop, but it's a good drop because it's the indexing time, how long it took to actually index all those documents. And if we basically index the same documents, but it's suddenly 10% faster, something obviously went well, and we are happy with the result. Again, all of those are open, so if you want to take a look at that yourself, you can totally do that. And of course, we do more testing. I think we have about 1,000 builds from across all the Elasticsearch branches per day. We recently added 2 more branches because of release plans, which means there are even more builds nowadays, I would say. We test all pull requests. Whenever someone of us updates a pull request, we trigger a new build, and we only merge pull requests if all of the tests are green. Like, there's no exception to it, and that's a pretty good idea. I think everyone should do that. And it also means you probably have to wait some time until you either get a free slot in CI and until the test runs are finished, but that time you just won't merge this PR. We test on different operating systems. I already mentioned that. I just want to make sure, like, if you have a product where you have to support several operating systems, you should probably make sure your CI reflect that. We need to test on different JVMs within Elasticsearch. There's the official Oracle JDK, there's OpenJDK. Amazon came up with Corretto a couple of months ago. There's the Zulu JDK, different package JDK. There are a couple of different ones, so we have to make sure that we, on the one hand, have a list of officially supported JVMs, and then on the other hand, we also test the other JVMs if we ever want to officially support them. We have to test with different garbage collectors. Elasticsearch ships with the CMS garbage collector by default, concurrent mark and sweep. However, this one is marked, or is going to be marked as deprecated in the JDK, so at some point in time it's going to be removed from the JDK. This means we also have to test with different configurations and different garbage collectors. So there's tests running with G1. Nowadays we also have options that you can easily enable G1 if you want. It's the default GC in your JDKs. And there are a couple of more interesting garbage collectors coming up. There's Shenandoah and there's ZGC by Oracle, which are sort of pauseless and short garbage collectors, and once they are stable, we will have to add them to our test matrix as well. Feature branches. We try not to have feature branches. Like, I had a feature branch for, I think, 6 months until I closed it a couple of weeks ago, and it's hell. Like, because we have 50 people working on the Elasticsearch code base, you're constantly merging. And I added this feature branch because it touched a lot of code across very many different modules. So whenever anyone else had something that I had a merge conflict with, it was on my plate to resolve this. I don't want to do it. It's pretty simple. So feature branches is something we try to not have, but if we have to, we obviously have to add them to CI as well. The nice thing is it basically just takes 4 or 5 lines per feature branch in our CI configuration. We push it, and from then on, CI runs on each commit that you do on the branch, and CI runs also in like regular intervals. Yeah, the last thing here is the documentation CI. I already mentioned that all of our products have a docs directory which contain ASCII doc, but we want to be able to cross-reference and to cross-link documentation. So if you're reading the Beats documentation, we want to be able to link into the Elasticsearch documentation and make sure this works. So we have, again, a dedicated CI job which is making sure these kind of cross-references work. So if you have more than one product, this might be something to check out, because otherwise people will click on dead links. And last but not least, I've been talking a lot about testing, and it's a lot of work, right? And we have a lot of failures. Like you saw the red bars when I showed the Kibana chart, and we don't want all of the 50 developers in the Elasticsearch team to constantly look at those failures. So we basically have something called test triage, where one person is doing nothing else the whole day, then looking for the failed tests, looking if they are reproducible, which also may mean to get the proper operating system up and running, or the proper JVM. We also test like FIPS JVMs for encryption standards, and make sure that if it's not reproducible, or if it is reproducible, create GitHub issues, make sure the GitHub issue is assigned to the correct team. Because if we just run all of those tests and no one takes a look at them, we could just stop it and save a lot of our Amazon builds, right? So we have to make sure we properly take care of testing, and the ultimate goal is, of course, getting an always green build here. But even with all this testing, it still means you have to do some sort of manual testing, and especially across a stack. especially like Elasticsearch is a luxury because we're a backend system, and this usually means we test our stuff and we know it works. But if browsers come into play, like in Kibana, and you have like 25 different browsers to support, things are suddenly a lot more complex again and need like more manual testing. So within the engineering team, there's a dedicated QA team doing like different kinds of testing, cross-product testing, but also integration testing. Sometimes it's hard to set up automated systems. Like imagine our Elasticsearch Hadoop integration, which needs to work with Kerberos to execute some sort of MapReduce job. Like just the setup for this is so massive that it's still pretty hard to actually automate. So preparing and testing release. This was the kind of tests we have. Let's assume we're happy with the tests. How do we do a release? First thing is, at some point we decide this is a point in time where we want to have a release. So basically we create an issue in one of our internal repositories where we state like, this is the release, this is the estimated release time. The guy there, that's Joao over there, one of my colleagues of the Logstash team. He's the appointed release manager for this release, which means he will be the one creating all the artifacts. He will be the one who says, okay, this is ready now, we can release it. All the links you're seeing there is basically things where we found either bugs or blockers where we said, okay, we can't release this until this is fixed. You basically add a link there. This down there is a checkbox, and only if that checkbox is checked, or only if all of those checkboxes are checked, we can actually do the release. And of course, this can lead to a bit of discussions back and forth, like a bit longer, even longer. But the ultimate goal of this, after we have had all the discussions, solved all the blockers, make sure everything works as expected, is of course to close this issue. And closing this issue basically means we did the release and you can finally download it officially. So what do we do and how do we do it? What does releasing mean? The first thing you actually want to do is, it should be easy, right? Like, there are so many jobs within our industry where people really don't like to take it because it's either complex or they're scared of it. Like my #1 example is always being on call. No matter how much ops experience you have, I don't know of a lot of people who are like, oh, hell yeah, I really want to do on call today. And you should try to reduce these friction points. And the same accounts for releasing. Like, we want to make sure that everyone within the engineering team, no matter if management or backend developer or front-end developer, is able to create a release. What does this mean? Well, we solved this by having a dedicated repository for this, which basically only contains a Vagrant file and a Gradle file. So all the requirements you need to have locally or on an Amazon machine is Vagrant plus a Windows plugin, because we create a Windows installer for some of our products, VirtualBox and Gradle. And that's pretty much it. Apart from that, the Vagrant image is doing all the job. It installs the whole technology zoo I was talking about at the beginning. It builds all of the projects. It creates all the package repositories. It signs all those packages. It uploads to S3 so we can run internal testing. It uploads to staging repositories, for example, of Sonatype, which is for Java dependencies. But there are a couple of other similar things for dependencies where we do this. So there's a lot of things. And the result of this is, and this is important, are final and immutable artifacts. Like, we create sort of one directory with only a single, or one directory, and this directory cannot be changed or written. Like, you don't go there, change a file in order to make everything work. Either those are the artifacts which are at some point in time released to everyone, or we create new ones. But we don't touch those anymore. What we really don't want to do is creating a build saying, okay, this version works well, and then starting a new build and creating completely different artifacts. Like, this doesn't make a lot of sense. You really want to make sure that the artifacts you create initially that are tested against it are the ones which are finally going to be released. So how does releasing look like? Basically like this. The release manager runs Gradle release, and again, we have all the magic happening in the background. That stuff from internal S3 repositories gets copied over to the official ones. And then everything is done, right? Well, everything is done from a developer perspective because the artifact is somewhere where it's publicly reachable. But of course, there's more work to be done, right? Maybe you need to upgrade the documentation properly in your CMS. Maybe you need to publish blog posts, update website download links, update forum posts, all these kind of things where you have to reach into other third-party systems which are maybe harder to automate or which don't make sense to automate. If you only have a release every couple of weeks and someone needs half a minute to update a link, there's no reason to really fully automate that, right? Also, there might be some post-release work. Like in the Elasticsearch repository, there's one file we have to update to make sure that our backwards compatibility tests are running with the just latest released version. So there's always something to do after a release. And also, think of software in terms of a life cycle, right? It's not that you don't continuously just push out artifacts. If you're commercially supporting software, you also have to let it die. You also have to say at some point in time, like, I'm sorry, dear customer, this version is so friggin' old. Hello, 2.x user. Please don't use it anymore. Please try to upgrade. So at some point in time, you have to say, like, this is the version, this is the date it's not going to be supported. This is the date where we will not add any bug fix to it, make sure it's upgraded. And if you have your fair share of products, obviously you have a fair share of dates. But you can see here, for each of the versions that we have, there's a date when it's not going to be supported, and there's also a version where it's superseded by. And this, on our case, basically focuses on major versions. So if there's a new major version, at some point we can decide to not support the major version -2. All right, I'm almost done. I just have a quick summary, and that's it. What did we learn? First, automate your releases. Make sure you don't touch them. Like, have immutable artifacts. It's super important from my perspective, because only this way you can just always create new releases and don't worry about who's doing it. Do this whole automation as early as you can. We basically just did it when we introduced Elasticsearch 5.0, where we already had this zoo of other products which we had to unify. And this release manager I was talking about was a lot of work to get right. And we still don't have all of the products in there. There are still some, like, satellites. We keep adding them, but it's just a lot of work and it takes a lot of time. Make sure everybody can do a release. If it's easy, people will do it. If it's hard, you suddenly will have less releases. And that should not be the reason why you don't have releases. There's no need to really automate all the aspects. If there's something that can be done within half a minute, then please just do it as part of a checklist, but don't spend like 25 engineering days to automate it, right? And last thing, does this work for you? I have no idea, because I don't know so much about your setup. I'm curious, like, if you spotted anything which is dead wrong in here. Of course, it always depends on what you're doing and how you release. If you have a software as a service system and you can just keep doing releases in the background without your customers noticing, that's pretty awesome. This works if you have a web-based platform. Of course, if you really have a product that you ship to your customers, that your customers can download and use from there, this does not work, which means you have to deal with releases. You have to deal with bug fix releases. You have to deal with potentially releases which are just to one customer to really, really test them. So this is all things that you basically have to keep in mind. All right, I'm almost done. I will put a link from the presentation into the Slack chat later on and on Twitter. I have a couple of links in here. If you were interested in, like, if our CI setup really looks like that, you can just check out Elasticsearch ci.elastic.co and scroll yourself for half a minute through it. The benchmarks.elastic.co contain information about the nightly benchmarks. The rally one is our benchmarking tool. And basically, I've been talking a lot about the technical side of things. And as you can see, there's a lot of things about scaling here, right? Because we started with one product. Releasing is easy if you only have Elasticsearch. If you have Elasticsearch, Logstash, Kibana, and Beats, releasing suddenly gets much more complex. So this is, at the end of the day, this whole thing is also a scaling problem. And if you're more interested in the human parts of this, like scaling an engineering team from 200 to from 50 to 250 people, there's another link for a presentation in there. Today we are like more than 500, so this presentation is hugely outdated, but we still learn a lot of things like how this works in a distributed manner, so it might be interesting for you. And yeah, I have no idea if we have some time for questions left or we don't.
We have some minutes.
Awesome, so we take a few questions and then we have lunch.
Yeah, thank you for presentation and thank you for release naming scheme. This is really convenient for end users. Question about cross-product releases.
About what? Sorry?
Cross-product testing of releases. Like, how do you trigger them? Like Kibana version 6, referencing Elasticsearch version 6 snapshot. Do you internally reference snapshot releases, or do you cross-test between current development version and release of your dependency?
It depends. So we test snapshots, for example, if just a new feature has been added and it should be tested. But the moment we have this development release, we have those final immutable artifacts which get tested and no snapshot versions, because those are the ones which get delivered at the end. So those are the ones which we test against. But if there's a feature which is still in development, you obviously have to go with a snapshot. So it depends on the case.
Yeah, so you do it during development, yeah? So it's not tested at the end of release, yeah? So you do it continuously, let's say.
Yes, yes. Also the QA team is doing continuously testing.
Yeah, so you have kind of continuous delivery in your pipeline. You just don't deploy it automatically.
Yeah, I mean, that's a great thing. If you have releases, you don't deploy your own software, right? It's awesome. You let others do it.
Yeah. Thank you.
With the exception of cloud as a service, of course. But from development perspective, yeah.
Hi, Alexander. Thank you for your talk. In the beginning, you mentioned that there is Elastic Cloud, and you also testing Elasticsearch against the cloud. But during the talk, it didn't mention. Can you say something about it?
So Elastic Cloud was basically running Elasticsearch as a service by our own team. It's not the development team, but we have a dedicated Elastic Cloud team who run Elasticsearch as a service. And I forgot to mention that they are also part of the release, and that's a valid point, because when we officially release an Elasticsearch version, that's the moment when you can already specify this version within our own service offering. So there's a lot of more magic going on in the background, where the cloud team is basically testing this release artifact and making sure it works, and then also making sure it's immediately available the moment we do an official release. And this is something which basically also only Elastic can do, because we release Elasticsearch and we can also release Elastic Cloud. And that is super, super useful to us. Answers your question?
Yes or no? Maybe do you know some details of how does it work, or it's?
No, I'm not involved in the cloud testing part there. All right, further questions?
This is the last question. Our time is up.
Okay, make sure it's good.
Hi, Alexander. Thank you for the presentation. My question is really quick. You mentioned you run some benchmark performance tests. Do you run any other type of performance tests in your solution?
Yes and no. So for certain things within Elasticsearch, we also have own JMH benchmarks, the Java standard Java performance method, which is only good for like really small pieces of code. Sometimes if we add a new feature and it's reasonably big, like for example, something like cross-cluster replication is a huge feature in Elasticsearch 6.6 and 6.7, which allows you to replicate data across data centers. We need to invest time to make sure that we can actually run between, for example, an Amazon and a Google Cloud data center and make sure it's fast enough. This is something we, again, tested manually in terms of having one person sitting there, being able to spin up 100 instances in one data center and the other and run those tests. So depending on the feature, you will always have to do some more specific and detailed testing. Or for certain cluster stability issues, we replaced our leader election algorithm in the upcoming next major version. And you want to make sure it not only works with 10 nodes, but also with 1,000. So we had, of course, tooling to start up 1,000 nodes in AWS and make sure everything still works as expected. But this is nothing which runs as part of our automated tests.
Gotcha. Thank you very much.